Hi, so I'm going to go over 7-3, explain it today, and it says find areas of trapezoids and kites. And so last lessons we worked on finding the area of rectangles and parallelograms, and we also looked at finding the area of triangles. So we're going to use those things as we work through this lesson. Here's a picture of a basketball key, and a key is from the baseline to the foul line on a basketball court. The problem says a European basketball key was changed from a trapezoid to a rectangle in 2010. The diagram shows the shape of the key before 2010, outlined in blue. So that's the shape, and that's what we call a trapezoid. If we look at the first question, it says that Tim finds the area of the key by multiplying the base by the height. So that means he's going to take this and multiply it by the height to find the area. Does that make sense? Well, really, what Tim is finding the area of is a rectangle. So if you see what I outlined is what, when we do base times height, what we find the area of. So we can't really use Tim's strategy because when we multiply 6 by 5.8, that includes these extra spots of triangles that are not included in Tim's shape. So no, Tim cannot find the area of the key by multiplying the base times the height. Okay, so the second part says, how could Tim find the area of the trapezoid by decomposing it into shapes he knows? What is the area of the key? So looking here, we can see by separating this out, we can find a rectangle and two triangles. Now my lines aren't perfectly straight, but triangle, triangle, rectangle. And we know how to find the area of those. So let's take a look at those sample work. Two vertical lines that divide it, which I showed you up at the top. The trapezoid is two triangles that are identical in a rectangle. So we can find the area of the key. We first find the area of the rectangle, which is length times width. We have 5.8 times 6. That gives us 20.88. One of the triangles is 1/2 base times height. So the base, we have to take the 6, take away the 3.6 because that's part of the rectangle, and then divide it by 2 because there's two triangles here. That gives us 1.2. So what that means is this little space right here is 1.2. So now we have 1/2 times 1.2 times 5.8 to find the area of the triangle, and that's 3.48. So in order to find the area of this trapezoid, we do the area of the rectangle, which is here, the area of one triangle, the area of the second triangle, and we have a total of 27.84 to find the area of the trapezoid. Okay, so this last part asks us to find the area of the kite. And there are two different ways that we can use triangles to find the area of the kite. And so I'm not going to do the math for it, but I'm going to just show you that you can look at two identical triangles by folding it down the middle, where this is your base, which is 8 plus 4. That's the first area of a triangle, is equal to 1/2 base times height. So we know what we need to find. So for that triangle, the base is 12, the height is 3. So another way to look at this is you could divide it into two triangles like this. So if both the triangles' bases are 6, the smaller one's height is 4, the larger's height is 8. As long as you find the area of both triangles, either way will get you the area of this triangle. So let's just try the one where they're the same, because then we can just multiply it by 2. So I have two triangles here. I'm just going to put my area equals 1/2. My base is 8 plus 4, which is 12. My height is 3. So you can use a calculator here if you want to. 1/2 times 36. Half of 36 is 18. So the area of one of the triangles is 18 feet squared. Since I found it for the two triangles that are identical, I just have to double that. And the area of this kite is 36 feet squared. You'll get the same thing if you use the other triangles. The math is just a little different in solving.